Okay, now that we know how to calculate H plus and OH concentration based off of the autoionization of water, now we can actually start flipping those concentrations and making them those tangible numbers that I was talking about before and putting them on that 0 to 14 scale, which is the pH scale. Okay, so in order to do that, we can use the log-based system to calculate pHs. And the equation's super simple. We're just going to say that the pH of a substance is equal to the negative log of the H plus of that system. Now, here's something important to realize. It's specifically H plus. Later in the video, I'll talk about when we use OH concentration. Okay? So you have to realize that you're going to have two ends of your scale. You'll have your 0 to 6.99, and that's where your H plus concentration is. Now, on the other side of the scale, say you're given OH concentration, you can say POH is equal to the negative log of OH. However, we don't care about POH. I care about pH because that's what my scale is set for, okay? So with that being said, pH plus POH is equal to 14, okay? So if I solve for POH, I can use 14 to figure out pH, which is actually what I care about. Okay, so let's look at some examples of this. So number 2 says, find the pH of a neutral solution. Okay. This one should be pretty straightforward. Hopefully you know that the pH of a neutral solution indicates that your H plus concentration is equal to 1 times 10 to the negative 7th, which means your OH concentration has to also be equal to 1 times 10 to the negative 7th, which means nobody outweighs the other person. They're equal, so this will be a neutral solution. So if my H plus concentration is 1 times 10 to the negative 7th, that means I can just say pH is equal to the negative log of 1 times 10 to the negative 7th. And hopefully if you plug this into your calculator, you get 7. Okay? So let's break that down a little bit to kind of think about what log means. So the negative 7th exponent, you have to remember, means that you take your decimal. So if I have 1 times 10 to the negative 7th, I'm taking my decimal and I'm going 1, 2, 3, 4, etc., all the way to 7, which means I have 6 zeros. 1, 2, 3, 4, 5, 6, and then the 1 carries the 7th place. What the negative log does to this number is it takes it in tens increments to get a whole number, okay? So it's going to go take a 10, take a 10, take a 10, 10, 10, 10, until it gets there, okay? Which means that it moved 7 times to get the whole number 1. And it moved 7 times to a small value, and that's why it turns it into a big value that we can put on the 0 to 14 scale. Okay, let's look at another example. It says find the pH of a solution that an acid has. So we have pH, again, is equal to the negative log of H plus. In this case, we have the negative log of 0.0001. And if you plug that into your calculator, you should get a pH of 4. Okay? Alright, let's look at number 4. This one looks a little different. It says find the pH of a solution that's base has been added so that the OH concentration is 2.5 times 10 to the negative 4. Hopefully your alarm bells are going off and they should be saying, we can't solve for pH yet because I don't have H plus. So we have to use our H plus times our OH minus is equal to 1 times 10 to the negative 14. Okay, so I'm solving for H plus. So H plus times 2.5 times 10 to the negative 4 is equal to 1 times 10 to the negative 14th. I'll divide both sides by 2.5 times 10 to the negative 4 to get h by itself, and I end up getting H plus concentration is equal to 4 times 10 to the negative 11th. So now I can plug that into my pH equation. So pH is equal to the negative log of H plus, which is equal to the negative log of 4 times 10 to the negative 11th, which gives me a pH of 10.4. Okay? All right, now what we're going to do is we're going to do some of these practice things like you did with your H plus concentration. Okay? So we're going to solve for OH, pH, POH, and then we're going to state whether it's an acid, base, or neutral. Okay? So I have the H plus, so ultimately to find OH minus, I'm going to do 1 times 10 to the negative 14th divided by 0.0001, and I should get divided by 0.0001, yep, that's what I thought, 1 times 10 to the negative 10th, which automatically you should already know this is the bigger number, so we're thinking that this is going to be an acid. Okay, the pH will be 4, which makes the POH 10, because these two together have to equal 14. Okay, let's look at number 2. So I'm going to do the same thing. I'm going to do 1 times 10 to the negative 14th divided by 0.0006 is equal to 1.67 times 10 to the negative 11th, which again, this is the bigger number, which is going to make this an acid. So I have to do the pH is equal to the negative log of this, so I'm going to say negative log 0.0006. The negative log, it comes out to be 3.22. And then to get the POH, I'm going to say 14 minus 3.22, and that gives me a POH of 10.78. Okay, I'm going to do one more. So in this case, we're given OH concentration. So to get pH concentration, H plus concentration, I'm going to do 1 times 10 to the negative 14th divided by 2.3 times 10 to the negative 5th. So the H plus concentration comes out to be 4.35 times 10 to the negative 10th. And you'll realize 5 is smaller than 10, which means it's closer to 0. So this solution is going to be a base. Okay, so to find the pH, I'm going to take the negative log again of the H plus. Even though it's a base, I still have to take the pH, I still have to take the negative log of H plus. So I'm going to say negative log of 4.35 times 10 to the negative 10th. So I get a pH of 9.36, which makes sense because it's a base, so we would expect it to be greater than 7. And then to figure out the POH, I'm going to say 14 minus 9.36, and I get a POH of 4.64. Okay, hopefully this makes sense. We'll do more practice like this in class. Thanks.